Today we will be solving integration of cosine of 2x. Now to solve this integral, we have to use one property, which is u substitution, and that we are going to substitute u by 2x. Now next step, you're going to take derivative on both sides, so we will have du equals to twice of dx. Now we need to replace 2x and dx. So over here we can write dx is equals to derivative of u divided by 2. After doing this, we're just going to replace this value over here. So we can write this as integral of cos u into derivative of u divided by half. In the next step, we will be taking this constant out, which is your 2. So we will be writing it as half of integral cosine of u into derivative of u. Now this you need to remember that to find the antiderivative of cosine, that is basically sine of u. So this you need to either remember or recall it from the memory. So we can write it as half of sine of u plus c being an integration constant. Now again we are going to replace this value, which is u, by 2x. So you'll be writing over here half of sine of 2x plus c, and this will be our final answer. Now we can also find out one general formula for this. So let's look at that one. So to find out the general formula, we can take cosine of nx dx, and you can straight off, by using the previous example, we can write it as sine of nx divided by n plus c. So we can straight off write this as this n or constant will come in division over here, but this will be only applicable if we have linear. So what are the example of linear equations? So we have, let's just say 2x is linear, 3x, 4x, and so on. Other examples can include 2x plus 2, 2x minus 3, 4x plus 5, and so on. So if we have these type of linear equations, then only we can say that, or we can apply this general formula. If we have a quadratic equation, so what are the quadratic equation? If we have the equation in the form of x squared, x cubed, or any x to the power n, okay, then we cannot apply the formula. Only in this case we can apply this formula. So this we need to learn.